Okay, so here I have a model with one main endogenous variable. These are endogenous too because they have one variable pointing at them, but this is the main endogenous variable that I have in the model. Now, I can see, and there are several indicators as well. So I can see, now I can see in version 8.0 onwards. If I go to this option, view save correlations and descriptive statistics for indicators, I can see the number of different values or unique observations for each indicator, and that number divided by the sample size, which is a relative measure of variation in the model. Now, here I have, even though my sample size is 300, I have these values that are quite small, 6, 5, 5, etc. The reason for these small numbers is that I am using Likert type scales that have 6 or 5 points, or I think all of them have six points, but not always the 6 points are used by the respondents. So strongly disagree to strongly agree. I can view the same measures for latent variables under here, latent variable coefficients. So I can see the number of different values and the number of different values divided by the sample size. And there is one problem with this small set of numbers here, 6, for the main endogenous variable, which is success. And the problem is the following. If so, whenever I analyze an empirical data set, which is what I'm doing here, an empirical data set with a sample size of um, 300. So my sample size is 300. This is an empirical data set. Whenever I analyze a model like this, a data set like this, I assume that the data set was drawn from a population, and I'm trying to understand what's happening at the population. So I'm trying to analyze the empirical data set to understand what happens at the population. And so my empirical sample should be a good reflection of what happens at the population level. But at the population level, the variable success equals a path coefficient times project management plus a path coefficient times e-collaboration plus a path coefficient times job satisfaction plus an error term. In this error term, uh, which is not really represented in the model, but if it was to be represented, it would be a variable here that would point at success. It accounts for the variance explained in success that is not accounted for by the predictors, which is 90% in this case. Because the R squared is 10% or point 0.1, this means that 90% of the variation or the variance in the endogenous variable success is not explained by the predictor. So it is explained by this error term, this structural error term. Now, this assumes that all the variables are standardized. So, so we have an error term, and this error variable is a random variable that is unique. And if you look at the distribution of values for this random variable, they're all different from one another, or most of them will be different from one another. So, what happens is that at the population level, success has a number of different values that is close to the sample size because of this structural error term. And if when I go to that option, latent variable coefficients, and I see that the number of different values, just 6, should be 300 or close to 300. And this relative percentage or ratio should be close to 1. When it is so low, that tells me that success as an endogenous variable is not a good reflection of what happens at the population level, which calls for a change in success so that it is more similar to what happens at the population level. And one possible change would be to create a logistic regression variable using logit, one of the algorithms, and then use this variable in place of the current indicator, which is success one. Okay, so the problem is that this endogenous variable is measured through a single indicator on a Likert type scale, is not even a ratio scale, and that leads to a degree of variation in the variable success that is too low to be a good reflection of what happens at the population. And so we can use logistic regression to produce a variable, which is a variable that stores probabilities that success will be high or above average, uh, and use that variable, and that variable will contain a lot more variation. Um, so this logistic regression variable creation procedure is covered in a different video, which is linked to warpls.com on that page under videos. So this concludes this demo on how to inspect, view a number of different values and the ratio of number of different values and sample size.